Question 3, if we were going to graph the bottom first, what form is this called? It's the factored form. How does the factored form help us? Easy to get the x-intercept. So let's use the fact that we have the factored form. Ooh, I like the way that sounds. The fact that we have the factored form. Let's use that to at least draw those 2 points in. We know that we're going to have non-permissible values at 1 and negative 1. The factored form, however, doesn't help us get our vertex. If I multiply this out, I'll start by foiling out the brackets. I'm going to get x squared minus 1 because it's a difference of squares. And then if I distribute my negative, I get negative x squared plus 1. Sometimes when you change it from factored form, this is just a expanded form here. Sometimes, like this case, it works out perfect. It's already in the vertex form. It's already in standard form. You can tell me what the vertex is by looking at this. 0 plus 1. Sometimes you're going to not get it into be, green. Sometimes you're not going to have it work out perfectly, that when you multiply it out, that you get it already in the standard form. Then you would have to complete the square. So it's a review of chapter 4 where we have to complete the square. Yes, Andrew? That's right. Once in the factored form, the other way to find the vertex, because parabolas are symmetrical, and we had negative 1 here and 1 here, we know that our axis of symmetry is at 0. So you could have just plugged in 0 and found out what y would be, and you would also get the vertex at 0, 1. Anyways, we now have our parabola. It looks like this. Okay? We went over 1, down 1. That matches up with our x-intercepts. If we wanted to find another point here, we could go over 1, down 3. And we would get more points like this as well. How many people are using the same color for everything here? So I will draw this one on a separate graph, because if you're using the same color for everything, the first thing we're going to do, now that we've got our original graph, is look at our x-intercepts and draw asymptotes. So we're going to get 2 asymptotes here. We're going to get 1 at x equals 1, 1 at x equals negative 1, and of course, we still have the horizontal asymptote at y equals 0. We then go to our points. We have a vertex. For sure, we're going to want to label the vertex. It actually stays the same at 0, 1. Now, we have our vertical asymptotes have separated it into 1, 2, 3 sections. We don't worry about when we're talking about sections, we're not worried about the horizontal asymptote. We're not thinking there's going to be things in all 6 of these sections, just the vertical ones separating into 3 sections. We've already got a point in the second section. That's the only point we're going to need to do for that section to graph it. We need a point in section 1. We look at our original graph. I have negative 2, negative 3. What's going to happen to that point? It's going to end up here at negative 2, 1 over negative 3. Probably should even be closer, right? There we go. Just make it bigger. In section 3, we can use 2, negative 3, and we would now have the point 2, 1 over 3. Once you have a point in each section, you can draw the asymptotic behavior. So we're going to have this here. With this single point, you have to decide if it's going to go up or down, but because we have an asymptote below, and because it's the vertex, and in this section here, the vertex is the highest point, so in our section, the vertex has to be the lowest point. So that's why you know in that section, it has to go up towards our asymptotes. And over here, it would look like that. So we get Batman. And the ones you can do for this one are 7, 8, and 11C. And I'll give you some time to work on that before we do example 4.